This project focuses on the application of machine learning classification on methods on the image natural dataset, which contains 6,900 images distributed into 8 different classes. The project includes data balancing techniques to handle class imbalances and applies 6 classification methods and develops a GUI application to classify the image in the dataset. Natural image, the dataset we are working with in this project consists of 8 categories. These categories are cats, cars, fruits, dogs, people, flowers, motorbikes, and airplanes. Each category contains between 700 and 1000 images of the relevant project. To start with, we import the libraries required for classification. The code reads and processes images from each category in dataset. Each image is assigned a label according to the category it belongs to, and the pixel values are normalized between 0 and 1. The number of image each categories is visualized in a graph to see in dataset balanced. This is unbalanced class dataset graphic. At this stage, we realized that there was an imbalance between some classes. To solve this problem, we used dump sampling, which reduced the number of samples each category to certain level, making all class equal. Categories with favor samples are left as they are. At the end of the process, our data is balanced with 500 samples in each category. This is balanced graphic. Separation of training and test data. We divide the data into trained and test sets. The training sets contains the piece of data that the model will use in the learning process, while the test set is used to evaluate how well the model performs this learning. In this project, we split the dataset into 80% training and 20% testing using the train test split function. We also made this separation repeatable each time by using the random state for two parameters. Confusion matrix. The performance of the model is analyzed with the confusion matrix, and this matrix, the rows represent the actual classes and the columns represent the classes predicted by the model. In the matrix, each cell shows the correct or incorrect predictions in a class. For example, there were 13 correct guesses for the cat class and 20 correct guesses for the airplane class. Dark colors indicate more predictions. This analysis allows us understand in which classes the model performs better, in which class it makes mistakes. KNN model. Since the KNN model is a distance-based algorithm, the data were normalized and scaled with standard scalar. To improve the performance of the model, K values between 2 and 50, Euclid and Manhattan distance metrics, uniform and distance weightings were optimized with grid search CV. In the test results, the model achieved 73.2% accuracy and successful F1 score in balanced classes. This results. The logistic regression The logistic regression model was also trained with data normalized with standard scalar. The regularization parameter C was set to 0.1, resulting in an accuracy 76.75% accuracy and F1 score 0.77. Results. The decision tree model was used to learn the distinctions between the data and the parameters max depth and mean sample speed were optimized with grid search CV. The model provides high accuracy in the airplane and fluid classes with an accuracy 70% and F1 score 0.70. 1 minute. This result. Classification in random forest. The random forest model provides a higher accuracy 78.7% and 0.821 F1 score by combining more than one decision tree and achieves good results, especially in the freeze and airplane classes. These parameters were optimized and model performance stabilized after 300 trees. Support vector. This model achieved 75.6% accuracy and 0.83 F1 score. CVM effectively learned the boundaries between the classes and provide a balanced result, but data augmentation over different kernel function can be tried to improve accuracy, example sigmoid or RBF. This result. Within the scope of the project, the dataset consisting of images was prepared for the classification process. The images were resized, converted to tensors of normalized. The CNN model was created to learn features from the data and classify according to these features. The model worked with 6 converged 2D layers, max pooling layers, and fully connected layers. The training process was accelerated GPU and with CUDA Sport. The model was trained for 30 epochs. The model was trained for 30 epochs. The first epoch started with an accuracy of 49.6% and a loss of 2.82, and the last epoch ended with accuracy of 82.4% and a loss of 19.97. Throughout the training process, the accuracy increased above 82% and the loss decreased significantly. These results show that the model adapts to challenging dataset and optimizes classification performance. The performance of the model on the test data was visualized. Predictions and actual labels were shown side by side to analyze the classes where the model was strong and weak. For example, Furies was incorrectly classified as person while cat was correctly predicted. The model performed well in most classes, achieving 78.9% accuracy on the test set, but some classes required improvement. This GUI code was written using Tkinter. All goal is load the image from datasets. See which of the following 8 classes is closer to which one the percentage terms.